Hey everybody, it's Mrs. C, and I am coming to you today with a little bit of an overview or intuition on some basic introductory function vocabulary. That's a lot to say. Basic, intuitionary, functionary vocabulary. So here it is. One of the things I'm asked a lot is, what is a relation? You get to hear this term a lot when you begin linear algebra. And I just thought I would show you a couple things. Sometimes it's easier to show you what a relation is than to explain it. So here's our first essential question. What exactly is a relation? All right, so let me just get this out of the way here, and let's take a look at our data table up at the top of the screen. So if I make this a little bit bigger, but not too big, okay. If I look at number 1 right here, it says f of x is equal to 2x plus 1, and I'm supposed to fill in for the f at x. Now, a lot of people already get lost with fx. What does that mean? F times x? No, that's function notation, okay? It's called function notation, and we use it to represent the output value. So if you put in a value into a table that looks like this, say, you put in a value, which are your x values, you get out a value, which are usually, we don't normally see the f at x, we see the value of y. So f at x means the function evaluated at x. That's a mouthful for somebody who's just learning this. So for now, just think of the fx or the f at x as another way to represent the variable y, the output value. So if you think of it that way, then it's really not that big of a deal, right? We have a function, the f at x, and we're evaluating the function at x for 2x plus 1. And then if you notice, they give us, up here in our little table, x values. So what we're allowed to do then is to plug in the value for x. So if I was to evaluate this function, for example, at 3, I would rewrite it as the function f evaluated at the value 3. And then what would I do? Well, I would rewrite this little equation as 2 times a negative 3 now, not an x, because I know what x is, plus 1. Well, what's 2 times a negative 3? It's negative 6 plus 1 gives me a negative 5. I'm almost out of screen down there. Whoops, okay. It's a negative 5. So my function, f, evaluated at negative 3, actually equals negative 5, and that is what I would put in the box. Let's try that again. Some of you are like, what? And others are kind of going, wait a minute, I think I get that. That doesn't seem like that big of a deal. No, it's not a big deal. It just looks a little bit like a big deal. So say we were to evaluate the function at negative 2 instead. That's what they're telling me my next x value is that I need to evaluate for. So I would write the function f evaluated at negative 2 equal to 2x plus 1 again. It's the same equation. Well, I'm just going to come over here, plug in a negative 2 instead, and evaluate it. 2 times negative 2 is negative 4 plus 1. Now I've got the value negative 3. So my y value, or my f at x, is equal to a negative 3. I think the hardest part is writing the little numbers. Okay, let's do it again. And that's exactly what you would do. You would input the values you're given for your x value, and output, or what would come out, would be your function evaluated at that number. And so if I go again, I say, what about the f at 0? That would still be the same equation, 2x plus 1, but I would be putting a 0 in here. Now, come on, people. 0 times anything is 0. So the only thing I'd be left with is 1. So that value would be 1. Now, function tables are really kind of cool if you think about them. They always have some kind of a pattern going on. Sometimes you can recognize the pattern and sometimes you can't. So, I think I left there. Okay. It's always interesting to see if you can actually find a pattern. If you can't, you don't need to worry about it because you can just go ahead and do the math. But it's always a cool thing to try to look for. Let me try another one. Okay, so let's do the function. Where's my eraser? Come on, eraser. There you go. Let's do the function evaluated at 1. Now, without all this extra notation, you can just write at this point 2 times a 1 plus 1, because that really is what we're doing. So we would have a 2, oh my goodness, plus 1, and we would have a 3. Now, any thoughts as to what you think this next value would be? Do you see a pattern here? Possibly you do, possibly you don't. Let's see if you're right. If we were to evaluate 2 at 2, right, plus 1, we would wind up with a 4. I'm having a hard time. I apologize. My things aren't coming out right. Equal to, what is it? 5. And you may have seen that pattern. We went -5, -3, 1, and then up 3, 5. What would be negative? Oh, excuse me, not -3. What would you then, based on the pattern, predict the value of +3 to be? Well, what do you think it's doing? It's going up, definitely, so positive, right? What do you think? Do you think 7? I'm thinking 7. Let's take a look at it. Maybe it'll be 7. So if the pattern continues, it appears like the value for 3 would be 7, because it went up 1, 3, 5, 7, kind of counting up with our odd numbers. So if we go ahead, we give it a shot, we would say 2, evaluated at what? 3, that's right, plus 1. And what is 6 plus 1 but 7? So really, you could just continue on and see where the pattern lies. All right, now, I want to take a look at this data, but in a different way, all right? So let's just come back here, and in fact, I think I'm going to grab my white marker, make my font really big, and where's my font? Make my font really big and just kind of give myself some room. So let's just get rid of all of this so I can work out here a little bit. Okay. So we have our set of data, right? A little data table. All right, once I start, you know me, I have to go and finish. That looks so much better. Okay, so once we have our data table complete, is it complete? No, a data table can go on forever. In this case, we could keep inputting values, but they gave me a set value of x's for my domain. So I want to go back here and just get rid of my little predicting, because when you're given a table with a set number of x's, you stick to that. Now, what do we call the value of all of my x's? My x's are referred to as the domain. So if you hear me refer to the domain, meaning the domain is set, I am talking about the x values. If I talk about my f at x, or my y, depending on what you want to call it, f at x or my y, same thing. We refer to it as the range. Oh boy. So if you hear me say domain, you know what I'm talking about. If you hear me say range, if I could spell the stinking thing, there we go. If you hear me say range, I'm talking about my y values, or my function evaluated at x, which is the y. So what is my domain? My domain in this given table is, we could say domain, or D, maybe with a little colon. Sometimes that's a nice little shortcut to not have to spell the word. And then we would set up a little bracket, and we would list the domains. So we have a -3, a -2, a 0, a 1, and a 2. Those are the values in my domain. So I use brackets to indicate that I have a set of numbers. That's how I do it. And then I'll use the parentheses to capture that set. Now, I'm not going to mark you wrong. If you were in my class, I wouldn't mark you wrong if you just did a parenthesis set. Probably wouldn't even mark you wrong if you just put a strand of numbers. But please put commas, because if you don't put the commas between them, it looks like one big number, and we don't want that. So what then would be the range? So I want you to look at that table and tell me, what do you think the range values would be? Okay, so we would have a -5, I agree, a -3, a 1, a 3, and a 5. They won't go on infinitely because I was given a set domain. So if my domain is set, then my range will be set. Okay, so my domain is the set of the numbers -3, -2, 0, 1, and 2, and my range are the values of -5, -3, 1, 3, and 5. That's it. That's all domain and range is. But you could ask yourself a couple other questions. Is there any other way to express a domain and range? And the answer would be, oh, yeah. You're going to see domain and range set in a kind of expressed in a lot of different ways. For example, there's this really cool thing that I like. It's called a map. A map looks something like this. It's two ovals with numbers inside them. And so they put the numbers for your X, usually on the left side. Your input goes on the left. And so they'll do this. They'll do -3, -2, 0, 1, and 2. And then they'll put the numbers that are in your range or your Y values over here. -5, -3, 1, 3, and 5. And 5. And 5. And 5. There it is. Oh my. And then they'll do a really cool connect dots. So they'll connect a 3 with the -5 and they'll draw a line. They'll connect the -2 with the -3. And this one's not a very fun map because it's just like 1 to 1. It's across like that. Sometimes they'll just use the strand of numbers in order and connect them to show you a domain and range. For example, if I was to give you a map that looked like this, and let's do it, and I give you the 1, 2, 3, 4, and then maybe over here I do 6, 7, 8, 9, and then I did something that looks like this. Oh, sauce. What if I did something that looked like that? Could you tell me the relation? What is this relation? Now, a relation, as opposed to we've talked about the domain and range, a relation is a set of the X, Y, or input outputs together. So we would look at our first input, let's call it an input, and our output, and show me who goes output. Output. Okay. What is my first input-output pair? It's a 1, 6. That would be expressed easily as the ordered pair 1, 6, like I just wrote. Give me another ordered pair that goes together. The 2 goes with the 4, exactly. So we could say 2, 4. Who goes with the 3? The 7. 3, 7. And who goes with the 4? The 4, 8. This is called a relation. And again, we bring them together with a bracket. This is a relation. Now I'm going to ask you a review question. Are you ready? Can you tell me the domain of this relation? Now remember, the domain are all your X values, your input values. So the domain would be 1, 2, 3, and 4. And notice, it's this oval. The input oval is your domain. all of those numbers are already expressed as a set of numbers together, a domain. And what would the range then be? It would be this output oval. And so we could easily identify the range as 6, 7, 8, and that's supposed to be a 9, which makes me realize, did you catch it? I couldn't read my own writing. That's supposed to be a 9. Okay, the 2 goes with 9. Those would be my ranges. So the domain is the X or the input, and the range is the output or the Y values. Now you can ask yourself, is there any other way that we could be given this? And the answer is, oh yeah. So this is a way that you can be given a domain and a range with no numbers at all. So let's take a look at what is this. Well, this is a graph. This is a coordinate plane, right? And it's a little maybe skew, you could say. It's not your typical symmetrical coordinate plane, because I really didn't need everything. But let's just equate ourselves with what we have here. Here's our x value. Oh my goodness, that's too big. All right, our x values are right here. That's my x axis, right? And so I think now, since I have to rewrite it, might as well remind everybody those are the negative x's over there, and this is the positive x's this way. We say negative infinity or positive infinity. Up here we have our positive y values, and down here our negative y values. So just to remind everybody, 0 is still the point of origin right in the center. Okay, so what you see is I have a little line, and really a line segment, right? I have a line segment in quadrant. This is quadrant 1. So as a review of our quadrants, you're going to hear that a lot. 1, quadrant 2, quadrant 3, and quadrant 4. So when you hear me talk about quadrants, that will be, you know, fresh in your mind, because I know you've heard those before. So what do we have here? We have a line segment. Just getting rid of some extra stuff. We have a line segment. It starts and stops for sure. And one thing I would ask you is to identify for me the domain and range of this function, or of this line that's been connected. So in order to do that, you would have to imagine the table of values that actually gave you that line. So let's take a look for a minute at our x values. Now, the x, I already identified the x-axis. That's this line, right? Then I'll just trace it for a minute. Now, if that's my x-axis, could I trace a purple line, but a purple line that would only be below the line that was given to me? Meaning a purple line that would not be way out here, right? Because this line that they drew for me is nowhere near out here, right? This is quadrant 2. So I would not want my purple line to be there. So I better get rid of this purple line here, because it's definitely not underneath my function. In fact, can you show me where I would start? Well, let's zoom in here a little bit. I would start right below this line. So I wouldn't want to have any other line except right on the X where this line appears to be starting. And it appears to be starting right there. Sorry, little axis, I just got rid of you. And where does this line appear to stop? It appears to stop right there at that. What value is that, guys? It's the, let's see, the 1, 2, 3, at the 4. So it starts at the 1 and it stops at the 4. So I would want to get rid of anything that goes beyond that, because my line does not cover any of the other x values. None of these out here. Look, there's no line above those. And so I would notice that my domain is going to go from 1 to 4. All values, not just the whole numbers, but the little decimal numbers too. For example, clearly at little 1.5, right, in between the 1 and the 2, I still have a line, look, Go all the way up. Boom, there it is. So really I have all this space, this infinite space that goes between a finite distance, 1 and 4. And why do I call it infinite space? Because I'm sure there's a math person out there that would say, that's not an infinite space. I mean, it's infinite in that all the decimal values between it, I could keep naming forever and ever numbers that go between 1 and 2. Think about it. There's an infinite set of numbers that you could write that would express the distance between 1 and 2, because I could say 1.5. I could say 1.55, 1.555, 1.55555. I could go on forever, just going between 1 and 2. Oh my gosh, it'll blow your mind. So anyway, I digress. My domain is all the values between 1 and 4. Let's not worry about how to write that right now. Let's take a look at the range. Now, where domain was all the values that were kind of on the axis below the line, right? The 1 through 4. And what I'm going to do is I'm going to erase all this extra silliness, and I'm just going to highlight for us the purple, which we said was between 1 and 4. Right there. That was very clear. That was our X. Now I'm going to switch colors for a minute. Let's go with a nice calm blue. And this time I want to look at this y-axis. Because remember, I want domain and range. So if I want range, I've got to figure out where does my line kind of overlap all my y values. But instead of going down to look at it that way, right? I don't want to do that. Wrong. I want to go that way. So if I start here and I go here, where do I hit? Because if I was to actually color it in, right, that would be the space that I would be looking at, because my line is going to go as low as here, and it's going to go as high as here. So it's going to cover the space between here and here. Now, I know visually sometimes that can be very confusing, but the more we do it, the more simplistic you're going to see it is. Because when I do all these colors and I find this little section of blue, all I really want to know is between what values did I just cover. So let's just get rid of all the extra stuff, right? The question is, what values are in my, what was it? Range. That's correct. So I cover what values in my range. Now, just to make things a little bit easier, because there's a lot of blue going on, my line, when I look at it carefully, went to about here, and from here it was clearly starting and stopping on a corner of one of my grids, we call them vertex points. So if you look at your y-axis, what values do we have? What value is this line? It's the 1, 2, 3, 4, 5. It's the 6. And we continue with 7, 8, and this is the 9. So my range actually goes from 6 to 9. Now I want you to look at something. Does that look familiar? My input values went from 1 to 4. Look over here. My input values went from 1 to 4. Let's go back. My output values went from 6 to 9. And let's go. My output values went from 6 to 9. So this, my dear children and people of the world, is the actual physical graph representation of a function that has a domain from 1 to 4 and a range from 6 to 9. It would look like this little line segment on a graph. And so, yes, they can give you a line too and ask you to state the domain and the range based on just a function. So at the end of the day, what do we know? Well, we know that we can be asked to find domain and range and establish what a relation is, right? So we know what a relation is. Hopefully it's a set of points. We know domain are all the x values, right? And we know that the range are the y values, or the function evaluated at whatever x value we're given. So we know all of that for the most part. We realize now, hopefully, that all of that information can be expressed in a lot of different ways. It can be given to us as a graph of a line. It can be given to us in some kind of a function table, and it can also be given to us in a map that we call this like a data map. And so there's a lot of different ways that this information can be given to us. And so what we need to do is learn how to move between the ways, kind of function, not to use the word function, it kind of work between all these worlds and be able to take data given to us in many different ways and understand what it looks like with the many faces, I call it, the many faces of a function, the different ways that we can actually express information in a function. So thanks for bearing with me. I know this was a long one. There's a lot of intuition that we have to go over with graphs, and there are a lot of videos on functions themselves because there are so many different things that we can do with them. So hopefully if you watch this, you have a little bit more understanding of just the basic vocabulary, so that as we move through, we can really dive deeper into the actual workings with all this, and we can have a proper vocabulary in which to communicate. So thanks so much for being with me. There'll be another video soon. I'll see you guys on the flip side. Peace.